All right, let's take a look at topic number 1. All right, we're going to review algebraic expression. Okay, so we're going way back to the beginning of your algebra. All right, so that's the way. So let's see. So in this particular video, we're going to talk about what a term is. Okay, very, very important. When we're dealing with algebra, everything we do is dictated by terms. Okay, a term in reality is like an object. Okay, one object is one term. So if you hold up two fingers, you know that's two fingers because there's a gap between the two fingers. That's how you know it's two fingers. Okay. So here, this definition is actually trying to say exactly what is one term looks like on paper. A term by definition is actually a number, a variable. It can be a product of some numbers. The word product in algebra means multiplication. So a multiplication of some numbers is only considered as one term. All right, quotient means division. So a division of some number is also considered as one term. So a number like a 4, a -7, and 8 is considered as one term. A single lettered variable, x alone, y alone, z alone, any variable alone by itself is considered as one term. So just like when we're solving for x, right? We will eventually end up with x equal to something. Well, this single letter x alone is actually considered as one term. All right. A product of some numbers or a multiplication of some numbers is considered as one term. That's a little bit tricky. Just think of this. 2 times 3 is equal to 6. 6 is a number, so 6 got to be a term. But the 6 come from the multiplication between 2 and 3. So multiplication between anything is considered as one term, one object. Okay. Multiplication between anything is considered as one term. So 2x, what does 2x mean? 2x means 2 times x. That's why 2x is also one term. All right. So within one term, okay, when you have multiplication, each number or whatever is in there is each one of them is called factors. Okay. So 2x has a factor of 2 and an x. Okay. Each one is called factors, but together they are considered as a term. What about xyz? xyz means x times y times z. So multiplication between anything is considered as one term. Okay. It just inside this term, I have three different factors. All right.
I can't
Division
see
of
what
some
you're doing.
numbers. Go ahead.
I can't see what you're doing, Mr. Chan.
Oh, I'm not sharing.
Oh, okay.
Am I sharing?
No, I don't see it.
Oh, sorry. How about now?
Okay, now I see it. Thank you.
Oh, no problem. Sorry about that.
Uh-huh.
All right. X, Y, Z, right? X times Y times Z. Okay. Together, because of multiplication, is considered as one term. All right. Three factors, but it's only one term. A quotient of some number is also considered as a term. Okay. Like a half. You know what I'm saying? 1/2. Now, this one is a very interesting one. 2x over 1 minus x. Okay. This whole entire quotient of 2x over 1 minus x together is only one term. But I'm not saying every fraction is a term. That's not what I'm saying. Okay. What I'm saying is division of some number is a term. So let me show you. If I give you an example of a division of a fraction, 3/4 divided by, 1/2. Division between anything, this is only one term. Okay. But if I were say 3/4, if I give you an example of 3/4 plus 1/2, now this is actually two different terms. So we're not saying every fraction is a term. Okay, we are saying the multiplication and division of some numbers is actually one term. Okay, so if you hold up two fingers again, how do you know it's two fingers? What separate between terms on paper? How do I know how many terms I have? Well, the way the way what we look at, what we're looking for is addition and subtraction signs outside the parentheses is considered, will help us separate between terms. So the 3 over 4 plus a half, I say is two terms because here I have an addition sign outside the parenthesis. So what's in front of it and what's behind this addition sign or subtraction sign is going to be one term. It just so that the addition sign will go with the terms that follows. Okay, so that problem, you have two terms. Okay, so how do we identify terms? Look for these addition and subtraction signs outside the parentheses first. And whatever is in front, in between, or behind these addition and subtraction sign is going to be considered as a term. All right. So this expression, 2x minus 3y plus 4. I see a subtraction sign and an addition sign outside the parentheses. So what's in front of the subtraction sign, 2x got to be a term. What's be in between the subtract and the plus sign got to be a term. 3y is a term. But the subtraction sign always go with the terms that follows. So this subtraction sign actually belongs to the 3y. So my second term is actually negative 3y. Behind the plus sign is a term. Okay, and the plus sign go with the 4. So my third term is going to be positive 4. So here I got three terms. So real quick, when you say plus and minus or add and subtract, all right, when you say plus and minus, right, 2x minus 3y plus 4. When you say plus and minus, normally those wording is used when we are dealing with operations. When we're looking at them as individual terms, we say the word positive or negative. Okay, same symbol, but two different perspective. Positive, negative, that means you're looking at them as individual terms. When you're ready to do the operation, you can say plus and minus. Okay, but when we first read the problem, we will say, okay, 2 times parenthesis 2 plus x. When you say that plus minus, okay, when those signs are outside the parenthesis, is considered as one term. Now this problem here, there's no plus sign or minus sign outside the parenthesis. What's between the two and the parenthesis is a multiplication. So technically, this problem is only one term. Okay, the problem itself is one term, but it's different if you were asked how many terms are actually inside the parenthesis. So you're now looking into this problem. You're looking inside this problem. In between the parenthesis, you see there's a plus sign. So that means inside the parenthesis, you got two terms, a positive 2 and a positive x, because there's one addition sign inside the parentheses, so that makes it two terms. Okay. So I always ask, I always use this example, 2 times 2 plus x versus 2 times 2x. What's the difference? Right here, what's the difference between the two? 2 times 2x, you don't see, you don't see any addition or subtraction signs outside the parenthesis. So technically 2 times 2x is still one term. So if you look inside the parenthesis here, 2x, there's no plus or minus sign. So inside the parenthesis, this is only one term. So now you got two problems, both of them are one term each. The difference between them is one of them has what? Two terms inside versus the other one only have one term inside. Oh, so what's the big deal? Well, the big deal here is the number of terms dictates how we go about doing the problem. Okay, you're not gonna do the the way you do the problem on the left is gonna be different than the problem on the right. So the way how we do algebra is always being dictated by the terms. Okay. Now this example here, I see a subtraction sign outside the parentheses. So this problem has two terms. In front of the subtraction sign, all these guys is one term. My second term is a -4. Okay. So this problem has two terms. Now, I use this example because in this class, we will eventually graph something look like this. So we also need to know how to key this into our calculator. So in the graphing calculator, if you simply type in x minus 4 divided by x minus 4, calculator calculator can't read this. Calculator read this as x minus 4 divided by x minus 4, literally. So this is not the same as what the problem says. Okay, so let's take a look. Your first term is a fraction term. So normally, when you have two terms and one of them is a fraction term, it's always safe to put that first term in the parenthesis when you key it in the calculator. Because your numerator has two terms, okay? Also, so it's safe to actually put x minus 4 in the parenthesis. Okay, so now this problem, now the way you key it in is you start up with the open parenthesis for your first fraction term, and you open another one for your numerator and type in x minus 4. You close the parenthesis for your numerator, then you can say divided by the x in the denominator and close your first term as a fraction. So now calculators see this as two terms. If you look at what I type in, see the subtraction sign outside the parenthesis. So now calculator read what's in front of it as one term, behind the subtraction sign as another term. It doesn't get mixed up. Okay. So that's what a term is. Okay. All right. So algebraic expression. So let's do some simplifying expression here. There's something you probably done before. All right. An algebraic expression is simply just something made of many terms. So if I would draw you a heart, a square, and a triangle, these three terms together is called an expression. Okay. So expression is just something made out of terms. Okay. They don't mean anything. They just, you can do things to them, but they don't mean anything. They just means you got terms, sitting right next to each other. All right. Like terms. We classify like terms as terms with the same variable and the same exponents. Okay. Because if you got terms that have the same variable and the same exponent, you can combine them. The word combine means add or subtract. All right. So if you got two terms with the same variable and the same exponent, you can actually combine them, or you can actually add or subtract them. All right. It's just when we actually combine them, all we do is simply add or subtract their coefficients, but we do not do anything with the exponents because the exponent is what I needed to classify them as a like terms. So a problem like this, 3n squared plus 2n minus 5 minus n squared plus n minus 4. You see there's a lot of plus and minus signs outside the parentheses. So here I got a lot of different terms. So let's find like terms. So when we combine like terms, we normally go by alphabetical order and or go by the exponents. So since they're all using letter n, we need to go by the exponents. So the square term go first. 3n squared is like term with negative 1n squared. So when you actually combine them, you say 3 minus 1, which will give you 2n squared. All right. Combine like terms. N to the first power go next. Positive 2n, positive 1n are like terms. So when you're ready to combine them, you say 2 plus 1, which is positive 3n. -5 and -4 are like terms. Okay, so when you combine them, you say -5 minus 4. Term with the same sign, you add. So that's why you get -9. Okay, I hope these kind of ring a bell. All right, distributed property. Let's do some distribution. So for distributed
Can you go back
properties,
up for a second?
mhm, distributed property says for any real number A, B, and C, okay, if I have a problem that says A times parenthesis B plus C, technically B, technically in the parenthesis, I got two terms, B and positive C. They are not like terms, so I cannot combine them. B plus C does not equal to BC. Okay, because these two are not like terms. So if you go by order operation, you're supposed to do the operation inside the parentheses first. Well, but what happens if you cannot do that operation? Then the next thing you can do is actually what use the multiplication. So distributive property says, okay, we will take the a on the outside, whatever numerical value we have on the outside, times both of these terms in the inside. So we say a times b, which will give me ab. Then we say a times positive c, which will give me positive ac. So distributive property allows me to bring all the terms to the outside the parenthesis. So eventually, what I can do is combine them with other like terms. And here is the subtraction version. A times b, which is ab. Then we say a times negative c, which is negative ac. Remember, every term can only have one sign. Okay, every term can only have one sign. If you ever wrote plus and minus, I actually don't give, do not give, do not give full credit for that. Every term can only have one sign. All right, let's distribute. Okay, this negative outside the parenthesis means -1. So here, since I got two terms in the parenthesis, then we will say take the -1 and distribute. -1 times 3, -1 times -r. -1 times 3, -3. -1 times -r, positive r. All right, these are not like terms, so I cannot combine them. So that's all you do. All right, the example on the right, let's see. Subtraction sign here, outside the parenthesis, plus sign here, outside the parenthesis. So my first term got to be 4a. My second term, -3b. Behind the plus sign, all that is one term. So my third term got to be +2 times parenthesis a plus b. So my third term contains the parenthesis with two terms inside. So we got to do a distribution. All right. So +2 times a, +2a, +2 times +2b, +4b. My second term still -3b. My first term is still +4a. So you see distribution allow me to bring out all the terms. All right. Now, once I bring them out, then I can combine whoever I can combine. I see 4a is like term with +2a. So when I combine them, I say 4 plus 2, which will give me +6a. -3b, like term with +4b. So when I combine them, I say -3 plus 4. All right, term with different sign, we will subtract. So that I should get +1b. You can write +1b or you can write +b. It doesn't matter. A lot of students ask me, Mr. Chen, can I combine like term in the calculator? The answer is no and yes. You cannot type in -3 and then choose the letter B. Where's B at? And then plus 4 times B. That does not work. Okay. But what you can do instead is remember when we combine like term, all we do is add and subtract the coefficient. So if you say it right, you're gonna say this is -3 plus 4, and you get positive 1b. Okay, you can do it like that, but you cannot type in letters and trying to let the calculator combine for you. All right, let's review a little bit on fractions. So here I got subtraction sign here, outside the parentheses. So I know my 2/3 x is one term. My second term, -2 times all that. So my first term stays as 2/3x. Second term, all right, God has a parenthesis with two terms inside of it, so I gotta do a distribution. So -2 times 3/4x, -2 times 3/4x. So -2 means -2/1. Multiplication of fractions, we will reduce before we multiply. So the top two, bottom four can be reduced into 1 and 2. So that would be -1 times 3, which is -3, over 1 times 2 is 2. So that'll be -3/2x. -2 times -2, positive 4. All right. Combine like terms. So this and this term can be combined. So I'm going to do this on the side here. Add and subtract fractions. We will always find the LCD first. So the LCD between 3 and 2 is 6. So I can either write 6 twice or I can write 6 just one time. Once you find LCD, the LCD stays the same. What we're trying to combine is the numerator. So sometimes you will see me write just 1 6. All right, 3 become the new denominator 6, got to times by 2. Numerator times by 2, so that will be 4 minus. Old denominator 2 become the new 6 times by 3. Numerator times by 3, that will be 9. So 4 minus 9, term with different sign, we subtract. So that will be -5/6x plus 4. Okay, so just real quick showing you, remind you how to multiply fractions and add and subtract fractions. Okay. All right, let's review. Okay, so that's it. So let's go over the homework. I always try to go over the homework. Okay. So most of these come from the handout or some of the things I talked about. So a term is a what? A term is I need you to enter all these definitions. A term is a number, a variable, a product sum number, and a quotient sum number. Okay, do that for question number 1. So you will find a lot of these answers, some of these question answers, just basically go back to the definition and concept. Is every fraction or rational expression a term? Yes or no? Is every fraction a term? Remember, I give you a division example and a subtraction example. Is every fraction a term? No. It goes by the operations. Multiply and divide, always one term. Okay, if you got two fractions being multiply or divide, that's one term. If you got two fractions that's adding and subtracting, that's actually two different terms. And I was hoping y'all see the difference. When I multiply, as compared to when I subtract two fractions, the steps are different because multiplication is one term, which you do it differently than if you were trying to combine two different terms. Okay, so the number of terms dictates how we go about doing the problems. All right, what's the difference between these two? As I mentioned earlier, what's the difference between these two? You can say both of them are one terms. The difference is the difference between the two is the number of terms inside the parenthesis. Okay, the one on the left has two terms. The one on the right inside the parenthesis is only one term. All right, question 4. Like terms are terms. So that's from the definition. Like terms are terms with the same variable and the same exponent. All right, so here we go. I'm going to show you this one. Do you see, if you actually go to homework, you will see problem like these, sometimes problem like these, you will have to enter as a using the graphic equation. So make sure when you do the homework, write the answer down before you key it in, okay? So number one, how many terms does this expression has? So use the subtraction and addition sign outside the parenthesis to identify your terms. Number two, enter the term that will need to be distributed. I need you to enter the entire term that you actually need to distribute. Okay, that's all I want you to enter. I'm not asking you to combine like term, none of that. I'm just asking you to enter the term that you need to distribute. Okay. All right. So that will conclude topic number one.